All right, so we're ready for part 2 of the 5.3 study guide. I wanted to give you this page one more time. I think it cut off before I got down here to detritivore and decomposer, and I started running out a little time, so got kind of rushed. Just letting you know, detritivores are organisms that break down non-living organic matter, okay, such as waste products like poop and dead material, rotting logs, things like that. And then a decomposer is actually going to break down non-living matter into smaller components. And those would include, breaking it on down into basic elements and things like that. Okay, so almost E-L-E, that is not election. Elements, E-L-E-M-E-N-T-S, okay? So breaking, trees down into carbon, or breaking rotten leaves down into phosphorus, things like that. So that's going to be more of a decomposer, just turning things into like totally abiotic factors altogether. So let's move on to page 3, 4, and 5, and I'm going to give you the answers to these as quickly as I can, since I've already given you a 20-minute video. Right? Okay. So this one says, how many trophic levels are there typically in any given community? So basically there are usually 3, I'll say 3, or 4, usually. Okay, so usually in a particular community there's going to be 3 or 4 trophic levels, and those trophic levels are basically going to be, steps or rings or rungs on a ladder. They're chains in a food chain, or chain link in a food chain, that sort of thing. So that would be the different trophic levels. So number 5, it says, what is true about energy transfer in communities? Well, the thing about the energy as it goes from the sun, if we were to draw, here's the sun. It's a green sun today, right? So here's the sun. The energy is going to come from the sun. Here it comes, and it's going to go to a plant. Okay, so here's the plant right here. Okay, there's the plant, and now the energy is in the plant, right? And then from there, it's going to go to, I don't know, some kind of an animal here. Here's a, I don't know, little, maybe it's a bunny. Okay, we've got this bunny. Well, let's back up here. So if I were to erase that E and erase this E, here's what you need to know. From the sun, this E is going to be huge. Okay, there's all kinds of energy coming from the sun. Well, the plant is only going to get about this much of that energy. Okay, so from the maximum amount of energy to the next level, the next trophic level, if you will, this is the first trophic level, we lose a lot of energy, right? So we have lost tons of E when we go from here, from the sun over here, down to the first trophic level. And then what happens when we go from the plant to the bunny? Well, that's going to become a little teeny tiny E, okay? So we've lost tons again. So it just keeps going down and down and down until finally, if we were to go one more step, okay, so I don't know, here's a stick person going to eat bunnies, right? Well, this stick person, by the time it gets to them, this is going to be so tiny. I'm going to try to make it as tiny as I can. That's not even right. Like, it's going to be even less than that. So I don't know how to make it any smaller with this crazy marker that I'm working with. So in that case, yeah, we're looking at, we lose energy every time we go. Here's another. Lose more energy as we go from one level of the trophic ladder to the next. So let's go back to number 5. What is true about energy transfer in communities? If you look at letter C, it says most of the energy in a trophic level is lost as heat. And you guys know that, right? If you were to take your hand and put it on your forehead right now, you're going to feel a lot of heat just coming right off of you. Or if you were to, jump out of bed and then turn around and put your hand on your pillow, you're going to notice that your pillow has a lot of heat on it, and that heat has just come straight from your body, and it's just been lost, okay? And so every time we go from one trophic level to the next, a lot of the energy that was consumed is actually just lost, okay? It would be like, I don't know, carrying a bucket of water, but the bucket has holes in it, and so it's dripping water everywhere. And so if you're trying to carry a bucket of water from here to there, and it's got holes in it, well, clearly by the time you get to where you're going, a lot of that water is already gone, and it's just lost. So that's kind of the thing about energy transfer from one trophic level to the next. Okay, so let's look at number 6 here. It says how much energy in one trophic level transfers to the trophic level above it. And the answer on this is only about 10%. So if you can think about that for just a minute here, let's say that you ate something that was, I don't know, let's say that there was a plant and it was 100 calories. Okay, well, how many calories are you actually going to be able to use to sustain your life? Well, if you only get 10%, that means only 10 calories is actually going to be used for energy for you, okay? In other words, if you need 2,000 calories a day in order to live and to grow and survive, imagine you're going to have to eat 20,000 calories of energy, okay, to even get what you're going to need. So just kind of letting you know that we have to eat a lot of food, and then that food loses a lot of its energy over time because we only get about 10% of what we eat we're able to actually use. So again, talk about a bucket with a hole in it, right? That's pretty crazy. So okay, so let's see if I can keep trying to like move this down a little bit here. Okay, so number 7, it says fill in the table and organize the information about food chains and food webs. Provide at least 2 characteristics of each. Well, a food chain shows a linear. This is linear. Okay, and remember I drew the fish from before, right? So that's going to be the little fish, and then the bigger fish, and the bigger fish, and then of course the bigger fish. So there they are. There's the fish. You know how I like fish, right? And then here's the little tiny fish. So that's going to be more like that. And then on the other way, for the food web, oh, and by the way, where does energy go? Well, down here, the energy is the greatest, and then as you go from one end of the food chain to the other, down here, it gets really, really tiny, okay? And each one of these levels is a trophic level. This trophic level to this trophic level to this trophic level, okay? And every time that happens, only 10% of the energy from the level below it is able to transfer to the next level. So super wasteful, right? Pretty crazy. So now a food web shows many paths. Okay, so this is going to show many paths for energy to flow. For energy to flow. So this one can be going in lots of different directions. Okay, so let's see. I'm looking at number 8 here real fast. I'm trying to cruise through these as fast as I can. I don't want to get sidetracked too much. I know you guys don't want to watch videos all day. So it says, what effect would the removal of a keystone species have on an ecological community? You know what? I know that you guys can write something about this. You can explain trophic cascades. You can use an example of the wolves, right? And we watched a video on the wolves. You can use otters. You could use, well, there were several others that we watched in those videos, right? So use one of these. Or the ones, let's see, the examples in the videos. To write this. And I would imagine a 5-sentence paragraph is going to work just fine for this. So see if you can get that done, okay? And I will be actually looking at this one very closely. This would be a really good one for me to see that you guys have actually learned some stuff. So do a good job on this one. I will be checking that one closely. On the next page, we're on to number 9 here. Let's see, some things that we have on here. It says complete the food chain below. Fill in the circle with one of the organisms in the word bank. So I'm looking on here, and I'm going to put in algae in the first one. I'm just going to pick one. You can do anything you want, but I'm going to do algae. And then that's going to get eaten by small fish. And that's going to get eaten by a big fish. And then that's going to get eaten by a bird, like an eagle or something. Well, let's see, let's put some stuff in here. So the energy over here, it's going to be 100%. Okay, this is going to be the big E. Here is going to be 10%. Only 10% of the energy made it from the algae to the small fish. After that, only 1% of the energy is going to make it to the big fish. Now you can see why the big fish has to eat so many small fish, right? And then finally, the bird is only going to get 0.1% of that energy. So over on this end, it's a very, very tiny E, okay, instead of a very, very big E. And if I were to label these things down at the bottom, this is going to be a primary producer. And then after that, we have an herbivore. And then after that, we have a carnivore. And then after that, we have another carnivore. It's not going to write. Hold on. I think I have to. There's like a dead spot in my screen right there, and it won't write right there. So if I bring it up, now it does. Okay, there we go. And then finally, when all of these things die, they all get to meet the decomposers at the bottom. P-O-S-E-R-S, okay? So they get to meet the decomposers when it's all said and done. All right, and then finally, let's look at 5.3, number 10. It says, what is an organism's trophic level? And the answer here is going to be the level at which they are getting energy, right? So an animal's trophic level is its rank in the food chain. Its rank in the food chain. And I'll say food energy chain. For example, up here at the top, if I were to look at this guy is in trophic level number 1. Here's the second trophic level, here's the third, and here's the fourth, okay? So wherever you are in the food chain is going to determine how much energy you're going to be able to get in the chain. And then let's look at number 11. Explain the 10% rule. The 10% rule states that only about 10% of the energy goes from one trophic level to the next. So I will put down here only 10% of energy is passed from one trophic level to the next. Okay, so just to kind of let you know how this whole thing works here, okay? 100% of the energy was here, then 10% is all the small fish got out of it, and then only 1% is what the big fish got out of it, and 0.01% is what the bird got. And that's why these animals at the top have to eat so much more, just because that's how they're going to have to get their energy. Okay. I think we are on the last page. We have to skip over this because that's a blank one. That's a blank one. That's a blank one. Is that it? Is that it? Did we do it? Did we do it? I think we did it. Okay. So I think we made it through. Yay! And I didn't even talk for 20 minutes, right? Thank goodness. All right. So if you have any questions about any of this, please let me know. What am I going to really be focusing on? I'm going to focus on this guy right here. I want to know what you know about this trophic cascade. And we've been talking about that a lot lately, so you should be able to do that 5-sentence paragraph pretty easily. Okay, hope this helps. Have a good day.